Let's do our second example for finishing graphing rational functions. We need to do step 6, our sign line, and step 7, graphing. So just a reminder, sign line, we put x-intercepts and vertical asymptotes on it. So this problem, from what we had done, we had an x-intercept of 1.5. So I'm going to put a point there. And I had vertical asymptote of -3. So just like a number line, -3 is less than 1.5, so I'm going to put it less. 1.5 is an intercept, so it gets a dot. -3 is a vertical asymptote, so it gets a dashed line. Now I start to think of my sign line. So remember, I'm going to put my numbers right here. And then I'm going to pretend that this -3 right there is my 0. So everything to the left of 0 is going to be negative. Everything to the right of 0 is going to be positive. And you'll notice I lining them up with the sections on my sign line. So now at 1.5, so this means 1.5 is going to be my 0. So all the sections to the left of 1.5 will be negative. All the sections to the right of 1.5 will be positive. Now, one note really quickly. There's one thing we need to keep in mind when we're doing this method for the sign line, and that's if anything is squared. So, for example, if I go up to my equation here, and this x plus 3 was squared, remember that squaring makes any negatives positive. So if this x plus 3 was squared, I would come to the -3 line and put the whole line as positive, because that square turns all my negatives into positives. So just a little side note, we don't have that in this problem, but if you ever do encounter a problem like that, that's what you do with it. Okay, now let's go through our sections. So this first section, I've got 2 negatives. So 2 negatives will make a positive. So positive. Then this next section, I've got a negative and a positive. So 1 negative and 1 positive means that section will be negative. And then here I've got 2 positives. So that's going to be positive. So now I got to box my sections on my graph. Remember, positive means above the x-axis. Negative means below the x-axis. So I'm going to go to the left of -3 and do above the x-axis. So left of -3, above the x-axis. Check. Between -3 and 1.5, below the x-axis. And you'll notice this time I actually put my signs above or below. That's just a little memory trick to help you remember which part of the graph you're boxing. Then to the right of 1.5 needs to be positive or above the x-axis. There we go. And now we graph. So if I look at this graph, remember that I need to go through any points I've got. So I've got 2 points there, so I need to go through those. I also know that I need to have arrows pointing towards my end behavior circles. Next, I cannot leave my boxes. I cannot cross an asymptote. So if I were to take this line down, it's going to leave my box, which is not okay. So that means it's got to, and it can't go sideways, because then it's going to cross the asymptote and leave the box. So that means it's got to go up. Now, I have some students ask a really good question. What if it goes down like that and then up? Still in my box, and it doesn't cross an asymptote. Your graph might do that. It totally might do that. We don't know. That's why this chapter is just about sketching these graphs. It's not about getting it exactly perfect. So if your graph could do that, I always like to take the path of least resistance. So I'm just going to put it straight up like that. Now, you'll notice here, remember, I need to go through these points. So here, I can just connect those lines, because now I point at my end behavior, I go through that point. And then here, I need to stay in my box. I need to not cross my asymptote. So it's going to go like that. And we're done. That's it for example 2. In the last video, we'll do the last example.